Hi, I'm Nicola Fox, and I am the Director of the Heliophysics Division at NASA headquarters. I am delighted to have this opportunity to be able to tell you about some of the new things that are going on in the division. Before I do that, however, I wanted to take a moment just to tell you what heliophysics is. So heliophysics is the study of our neighboring star, the Sun, and everything that the Sun influences. The Sun's atmosphere itself continually streams away from the star, and it moves away in a spiral pattern from the center of our solar system and reaches all the way out to the very edges. In fact, it kind of carves out a protective bubble for our solar system as we are orbiting around the Milky Way galaxy. And so this boundary, which is a very tenuous boundary, is really protecting us from the vagaries of interstellar space. Now, during this presentation, I am going to be telling you about some of the spacecraft that we have that are studying the various different regions from the Sun all the way out to interstellar space. Many of them exploring regions where we've never been before. But why should you care about heliophysics? Well, that's because the Sun really has an impact on us here at Earth. The Sun is a very dynamic star, and it can have many different types of eruptions that can cause particles and plasma to come rocketing away from the Sun at millions of miles an hour. And so you can see there a coronal mass ejection leaving the Sun, but also look at all those energetic particles associated with it. These particles are accelerated to about half the speed of light, and they stream down the magnetic field lines, causing impacts to your technology. And you can see that poor spacecraft there definitely getting big impact from those particles. But in addition to the particles, the main blob of plasma itself can drive big storms that occur here at Earth. And I'm talking about space storms, of course, things that power the beautiful aurora, but also can cause impacts to our technology. So we can have effects on our power grids, disturbances to radio propagation, and a loss of reliability to our GPS navigation. So many things that you rely upon every day are really susceptible to activity on the Sun and space weather here at Earth. So how do we study all of these phenomena? Well, the way we do that is to put observatories in exactly the right location to form this wonderful system observatory that you see here. Some of the spacecraft you see are focusing on the Sun, and others are focusing on the area around Earth, and others even further away, namely the Voyagers there that have actually left our heliosphere. We have continued to enhance and expand the Heliophysics System Observatory this year with new and innovative missions. We have a very robust suborbital program, and we continue to leverage creative rideshare strategies to get more science into space. You may notice many new missions since I showed this chart last year. One big change is the addition of Mars with the ESCAPADE mission to study the effect of the solar wind on the Martian atmosphere, and the RAD instrument on Curiosity, which we're in the process of transitioning to heliophysics to provide critical space weather data at Mars in support of the Artemis program. You'll also see IMAP, Punch, Sunrise, and ESCAPADE there that were all confirmed in 2021. We're also looking forward to confirming many of our other missions in 2022. We selected some missions of opportunity last December. EUVST, you can see there is a joint mission with JAXA to provide the next generation solar telescope, and EASY, 3 small CubeSats that are going to study the Earth's aurora. We've continued to invest in research and technology to enable enhanced research on science, and so with the IMAP mission, we will also be launching Solar Cruiser, that is a tech demonstration of a huge solar sail, and GLIDE, which is a science mission of opportunity that will be studying the Earth's exosphere and the impact of the solar wind and various other disturbances on our tenuous boundary to space. So as a result of all of these actions, NASA has the largest and most vibrant heliophysics system observatory in its history. So now let's look at some of the missions in the Heliophysics System Observatory. And here, of course, you see Parker's Solar Probe, who completed her 10th close approach to the Sun on November 21st, coming within 5.3 million miles or 8.5 million kilometers of the solar surface, and at the same time setting a new record for the speed. Current top speed of 364,220 miles per hour. And at peak speed during perihelion, Parker's Solar Probe could commute between DC and Baltimore in the time it takes you to blink. Just think about that. As you may recall, on our very first orbit, we discovered these strange features in the solar wind called switchbacks, little S-shaped curves that release energy that could be used to heat the corona and accelerate the solar wind. But the question of how switchbacks form has been hotly debated by the science team this year, with many competing theories being offered. Theories include reconnection, turbulence, and even slow solar wind being overtaken by fast solar wind on its way out from the sun. And I am sure that you will hear many talks during AGU addressing this very topic. But another major result for Parker's Solar Probe allowed us to shed new light on the structure and behavior of the inner solar system dust. Now, the zodiacal cloud is one of the largest structures in the solar system, and it's governed by meteoroid collisions near the sun. Collisional erosion occurs throughout the cloud, but it's been historically difficult to directly measure it. It's never been observed for discrete meteoroid streams. But after about 6 orbits with Parker, we were able to really take advantage of this flight path to get the best direct look yet at the most active region of the zodiacal cloud. Understanding the evolution and dynamics of our zodiacal cloud will allow us to better understand every zodiacal observation we've seen around any other stellar system. And what's exciting about this concept is that it's a fundamental process that will be occurring not only at every meteoroid stream in our solar system, but with every meteoroid stream to varying degrees in every dust cloud in the universe. So measurements have already helped researchers to better understand the collisional evolution of our solar system's dust cloud, and may also have provided direct observations of how a meteoroid stream collides with and erodes our own zodiacal cloud. Nice job, Parker. Solar Orbiter joined our fleet in 2020, and from then till now, Solar Orbiter has been in the cruise phase. And during this time, the in situ instruments have been taking measurements of the solar wind and other conditions around the spacecraft, while the remote sensing instruments that are designed to look at the sun have been in their extended calibration and characterization mode. But it is certainly time now for Solar Orbiter to start operating the 2 sets of instruments together as the mission shifts into the main science phase. And the anticipation, I can tell you, is palpable. In March of 2022, Solar Orbiter will make a close pass to the sun. Its first perihelion actually took place in June of 2020. But now the spacecraft is getting ready to do its second closest pass, providing a significant boost to the science that we can achieve. So Solar Orbiter does not go as close to the sun as NASA's Parker Solar Probe, but this of course is by design, because it allows Solar Orbiter not only to measure what is happening in the solar wind, but also to carry those telescopes that can look at the sun without being destroyed by the heat. So these 2 data sets together can then be compared and can be linked to the activity on the sun's surface and to the space weather around the spacecraft. So we cannot wait to start the operational phase of Solar Orbiter and get those 2 missions working together. So now all the way, we've looked at Parker Solar Probe and Solar Orbiter flying close to the sun, and now we go all the way out to our Voyagers, all the way out beyond the edge of our heliosphere, the furthest spacecraft from the Earth. They were launched in 1977 to do a grand tour for 5 years, and at the end of their prime mission, having completed all of those planetary flybys, they of course continued to travel out to the far reaches of our heliosphere. And so we've been able to use them to get really amazing interplanetary and now also interstellar measurements. And it's really allowed us to kind of expand NASA's exploration of the solar system beyond the neighborhood of the outermost planets and all the way to the very limits of the sun's sphere of influence, and then even beyond that, continuing our search for new phenomena and to help characterize the outer solar system environment. But now let's come a little closer to home and look at all of the missions that we have studying our closest region, our ionosphere thermosphere. So I'll start off by wishing Timed a very happy 20th birthday, as they just celebrated their launch anniversary on December 7th. Timed plays a really important role in our heliophysics fleet, because it's really only been in the past couple of decades that we've realized that the atmosphere is a critical part of our Sun-Earth system. So Timed's long-term data set has been very important, and it's really paved the way for several other of our upper atmosphere missions like ICON and GOLD, and also new missions such as OR and GDC. A recent science highlight from ICON was that scientists presented the first direct measurements of Earth's long theorized, but never observed, long theorized dynamo on the edge of space. It's a wind-driven electrical generator that spans the globe at about 60 plus miles above our heads. The dynamo then churns in the ionosphere, the electrically charged boundary between Earth and space. It's powered by tidal winds in the upper atmosphere that are faster than most hurricanes, and they rise from the lower atmosphere, creating an electrical environment that can affect satellites and technology here on Earth. Now, ICON was launched 2 years ago during a period of very low solar activity, at the very minimum, in fact, of the solar cycle. Now, of course, the solar cycle is clearly stepping upward, and so we have an excellent baseline to work from as we now look at the effect of more and more solar activity on that area. Missions like Timed and ICON have really paved the way for new exciting missions designed to hone in on the dynamics of our boundary to space. The video here is showing the 6 small spacecraft that will make up the Geospace Dynamics constellation. So this mission will use the upper atmosphere as a natural lab to help us understand our home planet and also other worlds. So it will allow us to study magnetosphere-atmosphere coupling and also look at universal physics of neutral gases and magnetized plasma, and really how those two things interact with one another. Now, the Earth's thermosphere is very similar to the Martian atmosphere, and so what we learn about Earth's thermosphere can be immediately applied to Mars. And so this makes the addition of the ESCAPADE mission to our fleet even more exciting. And so, what's upcoming? Eclipses. Really looking forward to upcoming eclipses. I'm sure you will remember 2017, as millions in the US were captivated by the first total solar eclipse of the millennium. Now, we have some new opportunities coming up in 2023 and 2024, and we are planning to design an experience that has there are 2 solar eclipses, and it also encompasses solar maximum, and we are going to use this to inspire a new generation with heliophysics science. We also are going to be including citizen science as a gateway to our missions and our science, and really achieve a broader vision for heliophysics by utilizing natural opportunities coinciding with the rise of citizen science. So we are sort of kicking this off with a very recent total solar eclipse that was visible from Antarctica. There was a wonderful live feed on NASA TV and a tremendous NASA Edge show, and I highly recommend you look at that or watch that NASA Edge show. It has all of the live feed from Antarctica and some great commentary from some outstanding scientists. But looking forward, we have October 2023. There will be an annular solar eclipse that will cross North America. And then in April 2024, a total solar eclipse that will also cross through North America. So it is providing a great opportunity for people in the United States to experience an eclipse. It also covers solar maximum. And not only that, but Parker Solar Probe will make that first final closest approach, that one where she is below 10 solar radii above the sun's surface. So much going on, the heliophysics big year. Please do get involved and join us as we inspire a next generation of heliophysicists. And I want to finish just by talking about a new initiative we have called Mentoring 365. So NASA has joined forces with the American Geophysical Union and 9 other scientific organizations to support students and professionals at all levels in the Earth and space sciences. And so that includes astrophysics, heliophysics, planetary science, earth science, and our new colleagues from biological and physical sciences, all through this program called Mentoring 365. It's a virtual mentoring program, and it will provide connectivity and access to a community of space professionals. So that includes scientists, engineers, mathematicians, writers, and more, all around the globe, and will facilitate the exchange of diverse professional knowledge, expertise, skills, insights, and experiences. And so I really do want to encourage particularly early and mid-career professionals to actually register to be mentees, and I also encourage everybody to register to be a mentor. I cannot stress the importance of having great mentors in your life. At every stage of your career, you really should both be and have a mentor. I, for one, have benefited tremendously from incredible mentors and role models in my life, and I just know that, how important they've been. And so please do visit Mentoring 365. The website is on the screen there, or you can Google Mentoring 365 and sign up to either become a mentor, a mentee, or hopefully you'll do both. And so I hope you've enjoyed hearing about just a few of the exciting things that we have going on in the Heliophysics Division. And we certainly look forward to sharing many more results with you as all of these new missions come to fruition. And of course, as we gear up to the Heliophysics big year in 2023 to 2024. So I can't stress enough, it really is a great time to be a heliophysicist. So please join us, keep looking up, and remember, Helio rocks.